For this next video, I want to take what you just learned about the second part of the fundamental theorem of calculus and expand on it just a little bit. So I want you to think, if I said the function, so if I said f of x is equal to the antiderivative from x to 4, and I'll just make this something gross that you don't want to integrate anyway, 5t squared minus 4 dt. In fact, you cannot integrate that one. We're not able to integrate that one with the skills that we'll have in this class. Take a moment, see if you can find a shortcut. What would be the derivative of this antiderivative? So what would f prime be? Okay, I hope you actually tried or thought about it at least. We cannot find the antiderivative of this. We can't. So we don't really know, we can't really try it out, but we can think about this logically. If we think about that first fundamental theorem of calculus, it would be whatever the antiderivative of that thing is with 4 plugged in minus the antiderivative with x plugged in. Sorry, that got a little tight there at the end. That's f of x. Sorry, no, we're not doing the derivative yet. So f of x would be whatever the antiderivative of that crazy function is, plug in 4, minus whatever the antiderivative of that is, plug in x. Okay, now it's time to find the derivative. The derivative of this is just a constant. We plugged 4 in. The constant, the derivative of that would be 0. And then what that would leave us with is the negative of what we started with. You might have already known that, but I just wanted to write it out. Okay, what about a problem like this? We're going to have to really be careful on this one. If f of x equals, just say we're going to go from 3 to x squared now. And let's stick with cosine t dt. I want to give you a moment. I want you to find that. I want you to find f prime of x, please. Do it all out the hard way. Pause and go do it. Okay, I hope you actually paused, and I hope you actually did it. I'm going to do this the long way, and then we'll see if we can generalize this. So if we have, for example, if we find the antiderivative of cosine is sine t plus a constant. If we evaluate that from 3 to x squared, we end up with the sine of x squared minus the sine of 3. The c's canceled out. Okay, so here's f of x. And if I'm asking you to find the derivative of this, then I need to use the chain rule on that first part. So if I use the chain rule, I end up with the cosine of x squared multiplied by the derivative of what's inside, which is 2x. And then the derivative of sine 3 is just 0. So let's look at how this is different than what we've been doing up above. It's still the same function that we started with. It's still the cosine. Still we replaced t with x squared. But because of the chain rule, we had to multiply by the derivative of that inner function. We had to multiply by the derivative of what we plugged in for t. Okay, see if you can do this one in a short way. If you want to write it all out the long way, be my guest. What if I gave you from 9x to x squared, let's just use cosine t because we've been working with that a bit. See if you can find that a short way. And if you don't know how to find it the short way, write it all out the long way. I want you to find f prime of x. Go ahead. All right, it's time we start shortening things up. I hope that when you did it the long way, to test your short way, you found some way that you might be able to generalize this. So if I know that the antiderivative of the derivative of this antiderivative will just get us right back to cosine again, What happens is, when we find that, we'll have the cosine of x squared because we plugged x squared in, so we need to multiply by the derivative of that inner function. Same on the second part. We're going to plug 9x in, so we'll have the cosine of 9x. So when we find the derivative, we're going to have to make sure we use the chain rule. So f prime of x equals 2x cosine x squared minus 9 cosine 9x. Okay, it's time to generalize the full second part of the fundamental theorem of calculus. So FTC part 2 in all of its glory, if f of x equals the antiderivative from some function u to another function v, so 9x and x squared, for example, f of t dt, f prime of x would equal what? Take a moment, generalize this, please. All right, generalizing this then, we know that we would have to plug v into the original function, f of v. And because we found the derivative, we'll need to use the chain rule. So this will be f of v times v prime. And then if we plug u into the function, that's f of u, multiplied by the derivative of the inner function, chain rule, u prime. So that is the full part, or full second part of the fundamental theorem of calculus. No matter what function we have on the top or the bottom, this will always be true. Even if we had a constant for v, for example. If v were a constant, then we would have f of the constant times the derivative of the constant, which would be 0. So that would all disappear anyway. So no matter which values we have there, u and v, the second part of the fundamental theorem of calculus is all taken care of. Okay, one last thing I want to talk about. This one's a short one. We've already kind of explored it in an FRQ. This is average value of a function. This is different than the average rate of change. We looked at it in an FRQ about the tree growing not that long ago in one of the videos that I posted. We looked at how a tree was growing. We used the trapezoidal rule to determine the total number of meters that tree grew divided by the amount of time. So the average value of a function is just finding the total from A to B of the area under that function. And then if we divide it by the number, or however long that time period went on, to be divided by however long that time span was. This is average value of a function. Do not get it confused with average rate of change. Average rate of change is a totally different experience. Average rate of change is just slope. So the question we had about the tree was find the average, a number of meters the tree grew in that time span from 2 to 10. So it was asking you how much, what on average per year, how much did the tree grow? I think that's going to be enough. I'll post another video in a moment where I'll go over one of the homework problems that has average value. But it kind of makes sense. I mean, average in general is just finding the total and divide by the number of things. And in our case, finding the total is the area under the curve. Okay, that's it.